Hello and welcome to our first ever MS SQL course here on the channel. Today I'm going to be teaching you guys how to go from your first select statement all the way through inner joins and a lot more smaller minute details along the way. Now my experience with MS SQL is that I've been a full-time data analyst for 2 years and I learned SQL shortly before that. So I'm going to be teaching you guys different concepts that I picked up both at work and also online questions like LeetCode and Data Lemur. This is going to be one part of a multi-part series where I teach you from beginner all the way to advanced, and I will be having a part 2 on intermediate concepts coming out in the future. With that being said, the software that I'm using in this program is SQL Server Management Studio. Now, it is not fully required to use this software to follow along, but I highly recommend that you download it and try to write line by line as I do this tutorial. I'm also going to be giving you guys examples to test out for yourself, so feel free to pause the video and attempt them before I share the solutions with you guys. And if you want to test out your skills after this course, I have a ton of different interview questions that I've posted on the channel, as well as other SQL concepts, and I'm uploading almost every single day, so make sure to stay tuned for new videos and subscribe to the channel. With that being said, I'm going to go on my computer right now and let's start this course. So before we get into our first ever select statement, I want to teach you guys about comments because I feel that they are just as important as specifically writing the query. And the reason is your code is often going to be shared within an organization. So there might be a DBA that checks your work, or let's say in 5 years, someone has to update a report. Leaving comments allows someone to know specifically what you did. Also, if you're going to be solving questions for an interview, leaving comments lets the interviewer know, like, all right, this guy knows what he's specifically doing for this task. And it just kind of helps you think about the specific query that is going on. So there's 2 different ways to write comments in MS SQL. Now, the first way is like this. So 2 dashes, and you can write whatever. This is a comment. Again, we can go down over here. This is another comment. And this is a line by line comment. So if I type right here, just this random string of letters, you'll see red because this is not a specific comment. But there is the option to have a multi-level comment. So the way that you do this is just like this. So you open up your comment right here. I can say, this is a comment. Again, another line. Another line. And you can see that it's still being a comment, but we did not close this out. So as soon as we close this out, you can see that we will have an error message. So I use a mixture of both of these. It's often really good to document it, what you're doing. So on a specific report, you might want to have this at the end of a line if you're adding in a new column or adding in a new calculation within your query. You might want to have a single line one like this because you can actually query to the left of this and then have this comment here on the right. And I'll show you guys this as we go forward within the course. Being said, I can delete all of this over here and we can start off with our first select statement. So I built a few different tables already within this database. The first one that we are going to be taking a look at is one called baseball stats. I'm a huge baseball fan and I wanted to build one out based off of different players and how many home runs and hits they have for their teams and specific leagues. And we're going to be using that a ton throughout this tutorial. So the way that we can do this is we start off over here and you have a select. Now you'll notice that I capitalize my select statements. A lot of different analysts do that. That way it kind of stands out within your query. Next, we're going to select the star. So this star selects everything within your table. The next line you want to drop down and we're going to do from. Again, I like it all capitalized so that way it stands out. And the table name is baseball stats, just like this. Now I'm going to execute this query over here and you can see how this table is built out. So we have the specific player, we have the team, the league, the batting average, hits, and home runs, which is really, really cool to see. I have another table in the database called Billy Strings Tour. The album right back over there is from Billy Strings, one of my favorite bluegrass guitarists out there, and I listen to him quite a bit. So I want to query this entire table which is called Billy Strings Tour. Now, same exact thing. We can do select star from Billy Strings Tour. And you can see that this populates right over here. And if we run this right now, both of these tables show up. You have all of this from baseball stats, and you have all this from Billy Strings Tour. We go back to what I showed you guys a little bit earlier. We can actually comment this out. You do this line by line. Now, if we run this specific query, only Billy Strings Tour shows up. You can also uncomment this. So go back over here and just delete these over here. And we can use the multi-line comment. So we want to have it like this and go like this. Again, just Billy Strings Tour will show up. So a few different methods on that. Now, I want you guys to pause the video. I'm going to delete all this over here. I have a table called Kershaw Stats, just like this. How would I select star from everything in Kershaw Stats? So pause the video, try it out, and then I'm going to go through it right now. So table is Kershaw Stats based off of pitcher Clayton Kershaw for the Los Angeles Dodgers. So all you have to do on this one is select, grab your star, and then from Kershaw Stats. And if we execute this, you can see the specific season and strikeouts for Clayton Kershaw. Didn't add it in 2023 since this season is still going. So the next thing I want to teach you guys is how to specifically choose a row within your table. So if we go back into select star from baseball stats, and we run this, let's say I just wanted to grab the player or the different batting averages, hits, or home runs. How could we specifically do that? The star grabs everything. However, if we just put over here player and we run this, you can see that the player has been selected. If we want to have multiple of these columns that are selected, we can do something like this. So what I'm going to do to show you guys is we're going to comment out this star over here, and we're going to add player. We're going to add a comma, and then we're going to do, let's say, batting average, comma, hits, comma, and home runs. And do not add a comma at the very end of this because you'll have a syntax error. So if we run this right over here, you can see player, batting average, hits, and home runs. If we added in that comma at the very end, you would see incorrect syntax near the keyword from, which is a hint for debugging, right? Because this is all red. Why is that red? Well, you have a comma here at the end, and that is not proper syntax. But when you are selecting your different columns over here, make sure you have a comma between each of these different fields. Now, formatting wise, this is not the best formatting for your query. Don't get me wrong, this is pretty basic of a query. It isn't too bad, but if you're going to be writing lengthy reports, or if you're going to have someone else checking over what you write, this is not ideal. So there's two different ways that you could really format this to make it look nice. I'll show you guys what I technically prefer, and I'll show you what some other guys do. So what I like doing is having each of these on separate lines like this, and then you can also tab it over. So when you are reading this specifically, you can see select and what's within this select. Now, some people have your from in all one line like this, so you can just comment out things and test it out. Other people prefer to have your from statement like this and build it out like this specifically. Now, this is optional. I would highly recommend you build out your syntax like this. Another thing I would recommend, or that you guys can test it out, is your comma placement. Now, for me personally, reading, I like having my commas all on the right. I've been trained to do that. But there are other SQL data analysts that prefer to have their commas here on the left, and there's a benefit of that. So I'll just delete all these over here. And you can see how this shows up like this. It's actually easier to debug. You can just easily, okay, done with this line, done with this line, done with this line, and test if things work properly. Again, I prefer on the right, and I'll just go in here sometimes and add my comments over here, but others prefer it this way. Really up to you, and you'll figure it out over time as you develop more reports or use SQL in your day-to-day basis. So let me delete all of these over here, and I want to show you something else that's pretty cool. So we're going to go back like this, and now I'm going to select the specific league from the table. So check this out. We have select league from baseball stats, and you can see that there is AL and also NL. But here's the problem. There's only 2 leagues in baseball, but we have 12 that show up. Why is that the case? Well, the problem is you're not using a distinct statement. Now, a distinct statement will only show unique results. So as soon as I put in distinct over here, you can see only AL and NL show up. So I want to give you guys a little bit of a challenge. So we're going to go back over here to the select star. Let's say I wanted to grab the distinct teams. How am I going to write that query? So I'll give you guys about 5 seconds if you guys want to pause the video. Otherwise, I will be going into it. So all you have to do on this specific one, and I'm just going to comment baseball stats, throw this over here. We're going to comment this one out, is select distinct team. I don't like it all capitalized, but you're going to throw it out like this. And then if you execute this query, you can see that there are 6 distinct teams out of, I think, 12 rows that we had in total from this table. Now, going back over here, sometimes in your database, you're going to have tables that are 10,000 rows, 100,000 rows, or even like 1,000,000 rows. And it's not efficient just to do a select star. So you might want to only query the top 100 rows. So that way you see what's specifically in the table, or you just want to do some testing. So the way that you guys can do that in SQL is go over here and select top 100. And this 100 number can change. You can say 10, 1,000, 10,000, 500, whatever you would like. But your top needs to be in front of it, that specific number. And this is before any of the fields that you are specifically selecting. So this table, if I did a select top 100, there's going to be 0 impact because we only have 12 results in here. But if I did only top 10, only 10 are going to specifically show up. We do top 5, do the same exact thing. And then you can add this element to a specific column. So what we can do, let's say instead of a select star, we're going to do top 5 player, and it shows 5 players over here. Or if I do 5 league, since we did not do a distinct, you can show that both of these are over here. Also, you can add in your distinct statement. So add in distinct top 5, and guess what happens? You only have 2 specific results. So test this for an example. Let's say we're going to select distinct top 5 for the teams. Okay, let's put this over here for teams. And actually it's team, not teams. And you can see that these 5 show up. But this is not always ideal, because what is really considered a top 5 team, or what's considered a top 5 player, we really didn't define that. We're just grabbing the top 5 results from the database. If you go back over here and you do a select star, right? Only these top 5 players are getting chose. Only the top 5 teams over here. Only the top 2 leagues. Like, there's no specific order on this table, which goes into this next element of SQL, which is the order by. So what's kind of cool is you have 2 different options with order by. You have ascending and descending. So that way you can, for example, with players, you can rank them A to Z, or also Z to A. But you can also apply this element to something like batting average, hits, or home runs. For example, if we looked at home runs, we can rank the players from the least amount of home runs to the most, or we can rank them from the most home runs to the least amount. So let's go through a few different examples, and I'll give you guys some questions to go through. So let's say we wanted to order by the home runs. So all you have to do is down below underneath your from statement, type in order by, and then just type in home runs like this. Now, by default, you're going to have it from lowest to highest. So 15 to 62. If you're going to do player names, right, it's going to be A to Z. So just type in player over here. And you can see that is A to Z. Now, this is called ascending. So if you wanted to clearly define the order by, all you have to put is ASC, and you can see it's exactly the same, right? If I did home runs, again, A to Z, 15 through 62. But if we wanted to reverse this, all we have to do is put descending. So DESC. And then you can see Aaron Judge's at the top with 62 home runs, which is pretty historic. And down at the bottom, you have Xander Bogaerts with 15. So my question for you guys to test this one out is, how are we going to do a order by, and we're going to do an order by for the teams in alphabetical order. So pause the video if you want to try it. If not, how I would do this is select distinct team from baseball stats, then order by team ASC. So I'm going to comment out this statement here at the top. And if we execute this, you can see we have teams Angels, Dodgers, Padres, Phillies, Rays, and also the Yankees. So we know that is working properly, which is really nice. Let's do another example. So we'll go back into baseball stats. And let's say we order by hits in descending order. And we're just going to grab everything over here. The way that you do this is you go down over here. We order by hits, DESC. And you can see Freddie Freeman had the most at 199. Then you had Trey Turner at 194. And it goes down from over there. Now, the most powerful tool that you guys are going to learn is the where statement. So if we go back into baseball stats and we just grab this and select the star, we have all this information, but a where allows us to filter it beyond just like a distinct. So let's say I only wanted to show players that had over 30 home runs. This would get rid of anything from Juan Soto and below. We can add that into a where statement. Let's say I wanted to have the team be in the American League. We can filter on this league column. If we wanted to have hits over 100, we can filter on this hits column. If we wanted to have players that only start with M for the first name, we can also have that. So Mike Trout, Machado, and Mookie Betts only show up. And all this comes down from your where statement. So know some of these start getting complex, but let's start on a very basic example. So let's take a look at an integer one with this. So let's say we want to only show players that have over 30 home runs. So the way that I would do that is where home runs is greater than 30. Pretty basic, right? And you click execute. And look at that. We have all of our players over here. And we can actually also use our order by statement to clean this up and present it a little bit better. So we want to do order by home runs. And if we execute this, you can see Stanton has 31. Judge has 62. Let's say I don't like this format. I want to have it in descending. And just like that, 62 through 31. So that's one version of using it by an integer. I'm going to just comment this out and we're going to run this. Again, the comments always super important to learn. So let's say for this example, I wanted to show, and I'm just going to look at this over here, see if anyone is equal in home runs. Looks like we have Freddie Freeman and Trey Turner who hit 21 last year. Let's say we want to have where home runs equal to 21. So equal to 21. Execute this, and we have two specific results. So You have a bunch of different ways that you can do this. If you want to also show everyone that had home runs greater than or equal to 21, you can throw this over here. And this adds a ton more functionality when you're trying to grab data specifically from your database. Let's take a look at an example now with a string. So we have a few different strings in here. We have player, we have team, and also we have league. So let's use a very basic one where league, and we're just going to have a select star on here. So where league equals AL, like this, single quotes, and we execute this. And we only had 5 players in this table that were in the American League. Let's say we want to do National League. Let's change that up. And look at that. We have 7 players in the National League. Let's say we wanted to have players that were on the Padres. So we need to change the team, where this is over here, team, and then we're going to put Padres. And we're going to execute this, and you can see that there are 3 within Padres. Now we can combine multiple statements under this where clause. So let's go over an example with the Padres. Let's say I wanted to only show players that were on the Padres and hit over 30 home runs. So the way to do that is we already have team equals Padres. You throw in here the and statement, and then you put home runs greater than 30. And check that out. We only had Manny Machado. So now we filter by both teams and home runs. So another statement that you guys are going to be using quite a bit is the or. So let's say I want to grab players who hit at least 25 home runs or had over 150 hits. So the way that I can do that specifically in here is first, let's say home runs is greater than 24. That way we can show anything that is 25 and above, or hits is greater than 149. And if we run this over here, you can see 11 players show up that fit either of these criteria. We can also change this. So let's say I wanted to choose 35 home runs or hits were over 149. Now this goes down to 9. And for the or to work, you only have to have one of these statements. So you could have either home runs over 35 or hits over, on this one, hits over 149 for it to work. So before we go into a little bit more complicated where statements with strings, I do want to test your guys' knowledge. So let's go back into here and let's write a few specific queries with all this information that I have given you guys. So our first query is let's select players that are in the American League that have over 40 home runs. Over 40 home runs, order by descending in the home run column. Okay. So that is going to be our first one. Our second one is we're going to grab players on the Dodgers or Padres that have over 135 hits. And on this one, we are going to order by the player name. And then let's do one more. So our third one is going to be pretty easy. We're going to order by National League teams in ascending order. So if you guys want to pause the video and try this, go right ahead. Otherwise, I'm going to start solving these with you guys. And real quick, also before I do this, I need to add in players over here just to define that specific column. So with that in mind, let's put over here, select players, or it should just say player. Then we need to select our home runs. And then it's going to be from and grab in baseball stats. Just like that. And if we run this query, you can see that this has the players and the home runs, which is great. But we need to fill in part 2. So over 40 home runs, which tells us that they need to have at least 41, and then order by home runs in descending order. So let's add in our where statement. So where home runs is greater than 40. Then we'll put and. We're going to do league equals AL like this. If we run this, you guys can see that there's only Aaron Judge. So if we order by descending, it doesn't matter, or ascending, because only one has hit the criteria. And I should put home runs here because I forgot to put that there. And run it, it's gonna be the same. So just for this use case, let's say we want to do 30 instead. So you guys can see a few different examples on here. We grab 30. This time we have Aaron Judge with 62, Mike Trout with 40, Ohtani with 34, and Stanton with 31. Okay, great. That one is working. Let's take a look at number 2. So this is players on the Dodgers or Padres that have over 135 hits, and we're going to order by the player name. Okay, great. It doesn't tell us ascending or descending, so we're going to assume that is going to be an ascending. So let's grab all this again. So we're going to select, and we're going to have our player, we're going to have our team, and we're going to have hits. We're going to do from, and we're going to put over here baseball stats. And to test this always works, go over here and player, team, and hits. And you guys will notice I always check my queries early on. I'd rather find out if I have a bug now than later after I write something that is a bit complex. Something I do, maybe it's a little bit of a waste of time, but I always check, even if I know I'm 100% correct. So we have player, teams, and hits. So great. Next, we need to start our where statement. So we have a few different things that we need to have our where. So team is either Dodgers or Padres. And then we have and they have to have over 135 hits. So I figure we should do our hits greater than 135 first. And then we'll have an and statement. This is a little bit of a tricky one. And we're going to put our or in here. So we're going to put our team equals Dodgers or team equals Padres. And I'll explain why I did this in a second. Now, if we specifically run it, you can see that there is 4 players: Machado, Bogarts, Betts, and Freeman. So let me explain why I did this specifically. So we technically have an and statement here that isn't clearly defined. And that is, we have to have 135 hits, which is our first criteria, and the player needs to be in the Dodgers or the Padres. So what I do, and I do this all the time when I'm coding, is I'll make the or statement within over here, which defines all the players that'll either be on the Dodgers or the Padres. And then I'll link these two together with this and statement. So that way we have hits over 135 and the players either on the Dodgers or the Padres. And this is kind of a basic example of it. You're going to get really, really complicated queries at times. So try to build it out like this. Other way, syntax-wise, I should also mention, some data analysts like to have each of the different statements on other lines. So some people like to prefer it being in one line like this for readability purposes. Others would prefer to have it like this. So keep that in mind. And obviously, I didn't keep the best syntax over here. If I were going to write this for a query I would have at work or like a stored proc or anything like that, I would just build it out like this specifically. But I'm going really fast teaching you guys this stuff, so that is why I didn't do this formatting. So just keep that in the back of your mind from readability purposes. Okay, so that one is working properly. Let's go into number 3. And this one is order by National League teams in ascending order. So this actually sounds pretty cake. So select, and we're going to do team because it's the only thing that we need, from baseball stats. And then we're going to see where league equals NL. And then we're going to order by team ASC. And if we run that over here, we have all these. But that is not correct, because one thing that I forgot, and if you guys remember from earlier, is this distinct statement. So we put over here distinct, and we run this. Now we have 3 instead of 7. Okay, so I hope you were able to solve all three of these, and it's not too complicated at the moment. I want to add one more level of complexity to these over here, and we're going to start taking a look at wildcards. Now, what wildcards allow you to do is look at a specific segment of a string. So if we go back into baseball stats, and I only wanted to grab, let's say, for example, players that start with the letter M, we could do that because I could have a wildcard over here that's would be able to select Mike Trout, Manny Machado, and also Mookie Betts. And it could be more than just one specific character, but I think that's a good starting place for it. So we go back into our where statement over here, and we're going to put where player like, and we're going to put over here, let's say M. Now, this isn't correct syntax because we actually need to have a percentage sign after that. And that lets us know that this M character needs to be at the very front and whatever else could be at the end. Now, if we had percents on both sides of things, we are just going to be looking for the M character. So I'll just show you specifically what this one looks like first. So if we execute this over here, again, you have only those three players, Mike Trout, Manny Machado, and Mookie Betts. But if we put this percentage sign like this, we have 4 players now because we have Freddie Freeman who has an M within his name. Let's say I wanted to select players that do not have an M in their name. Well, the easiest way to do that, honestly, is you just put here not like, and the other 8 players are going to be shown. And a lot of these wildcards are going to be used on programming tests. They don't have a ton of functionality within work, or I haven't used them that often. Maybe every work is different, but I see these all the time on lead code type questions. But there's also another level of complexity you could add onto these. Now you can also give a specific range of characters that you don't want to use. So let's say, for example, I didn't want to use M through P. Now the way that you could do that, and I'm going to delete this over here, put everything together. And if we run this code, you can see anything that is not M, N, O, or P as the first letter will not show. So anything over here, nope, M, N, O, or P for those first letters does not show. Or you can put different ones together. So let's say I didn't want to have A or X in here. And if we run this over here, you can see that Aaron Judge and Xander Bogaerts are gone. So either you can do a range or you can specify specific characters that you didn't want to have within this wildcard. Again, if I remove this not, now we're just looking for players that start with A or X and only 2 show. So if we go back in here and we just comment this one out, just for a one test question for you guys. Let's say we want to grab players with their first name that start with J and also T and that are in the National League, are in the NL. So how we would do that is we select, and we'll select player from baseball stats, just copy and paste that over there. It's at our where league equals NL and player like, and again we are looking for J or T, so J T and like that, and we grab this query, and that is only Juan Soto and also Trey Turner, both National League, and J and T. So up next, we're going to be taking a look at aggregate functions. While it's been nice to grab specific results, now I want to see specifically the average home runs for a specific team, or how many home runs a team hit, or how many hits has a team hit, or how many hits has a specific league had. And we haven't able to unlock that functionality until we've added in these aggregate functions. So let's take you through some of those examples. So our first one we want to see is the average home runs just in this database itself. So first one we want to see is average home runs just in this table itself. So all I'm going to do is type in AVG, just like that. And I'm going to throw in home runs. We'll close this out over here and we execute. And you can see that the average home runs is 29. Now, this column doesn't have a specific name associated with it. You can see it says no column name, and that's because we haven't labeled it. Now, labeling columns in SQL is very, very easy. All you have to do is type in as, and I can say home runs like this. If we execute this, now this has been relabeled. Or we can delete this as and just have home runs over here. And if we execute that, the same exact thing. So you have both of those options within here. If you want to have a space in here, which I don't recommend, but sometimes that happens, home run, space S, throw it in this, and you can see that shows up like that. But again, highly recommend that you do not. So how you can do that. And it doesn't even just need to be an aggregate function like this, just to show you guys again, home runs outside of here, kind of like that. But I figured this was a good place to finally show you this, as everything else would just populate automatically. So, okay, our average home runs is 29, which is kind of cool to see. Let's say our sum of home runs is 356, right? We can do min, we can do max. So min is 15, max. And now you have all these types of different calculations that are now built into SQL, which would save you a ton of time. But what the cool part is you can add in group by statements, and you could really filter this down. And you could also throw in the where clause. Now, we haven't gone over group by yet, but let's say, for example, I wanted to find the max home runs per league. So what I can do is put in over here league, and we put over down below group by league. And of course I misspelled league, but we can just have that normal. And you can see the AL, the max is 62, and the National League only has 35. But what happens if we actually don't have this group by down below? We'd have an error. So you see what would happen. Column baseball stats league is invalid in the select list because it's not contained in either an aggregate function or a group by clause. So anytime that you have an aggregate function, some of the different examples I showed you, max, min, average, sum, you always need to have a group by statement here at the bottom, because we're grouping by the specific league when we're looking at the home runs. We had, for example, over here, and I'll uncomment this group by, we wanted to grab the sum. We have that option. Again, if we want to do average, adds in a ton of flexibility. So let's go over a few different basic questions and go through them. So we'll grab this select star. And the first one I would like to find out is, let's say, how many hits, let's say sum, I should say sum of hits per team in the National League. So we're going to have an aggregate, we're going to have a group by, and we're also going to be filtering by National League. Fantastic. Okay. Let's look at the next one. So let's say let's say average of home runs per team in the American League. So that will be another one. And we will have those two to start off with. So the way we start off with this first one, again, feel free to pause it, is select, and we need to have our team over here. Then we also need to have our sum of hits from baseball stats and where league equals, and we said National League for this first one, so NL. Then we need to group by team so we can have that calculation. So again, always the group by is below the where. Grab that, and you can see Dodgers, Padres, and Phillies, but we did not name it, so we'll put total hits. Run it again, and we have that built out over here. I can just copy this over, and we're going to just make a few different changes. If we're going to do the average, which I put AVH here, let's put AVG. That's specifically what I want. So instead of sum, let's put average. Let's put over here home runs. And league, instead of NL, we also put in the AL. And boom, there we go. But I'd recommend changing this because we have total hits. This is average home runs. So home runs average. And run that again. 37, 20, and 46. So I actually want to branch off from the statement and, filter this a little bit more. So let's say I wanted to have, and it's me thinking on the spot, the average, I want to have the teams that have an average home runs over 30. So I don't care about the league anymore. We can actually get rid of this. And I'm just going to run this in general just to show you guys how this works. So we have 6 different teams over here. Okay, 37. So we don't want to show the Dodgers who average 28. We don't want to show the Padres 24. We don't have the Phillies at 19 or the Rays, but we want to show the Yankees and also the Angels. So how are you going to do that? Now, if you're new to SQL, you might be thinking, oh, we could just have a where clause. Let's try that, right? So let's put over here where home runs is greater than 30. And I'm going to tell you this isn't going to work. Because look, now we have these 4 over here when we only wanted the 2, right? Like, doesn't make sense. Why? This is actually filtering on the specific players that hit over 30 home runs. That is not what is being asked. I'm asking for the teams. So we Control Z this over here and go back over there. You can see the Angels 37 and the Yankees 46. Okay, maybe we can throw in the average statement in that where clause. So where, and we put average home runs is greater than 30. Maybe that will work. We run this. An aggregate may not appear in the where clause. Okay, why is that not working? How do we do this? Well, you can actually do this through a having statement. So what we want to do is from baseball stats, group by team, and then the next line down, we'll put having, and we'll say average home runs greater than 29. So that'll show everything is 30 or above. We run this query, and we have the Angels and also the Yankees. So when you want to filter specifically by aggregate functions, you're going to have to use this having statement. And you can actually use where and also having together. So let's say I go back to this one and we just want to have average home runs over 20 and select this. You can see that we have 4 teams. But if I just want to show the National League teams, we can put that back in here. So where league equals NL. And if we run that, you can see the Dodgers and Padres only show. So you can use both where, group by, and having all together. And you're starting to slowly build up some complicated queries. I still think this one's a very easy one. You might see something like this in an interview question. But once you stack on this type of stuff, as well as a little bit more complicated tables and subqueries, which I'm going to teach you guys in part 2, it'll be really fun. But that is how you can use these. I'm going to give you guys a few other additional questions real quick, just to walk through, and we'll move on to the next part. Okay, so I wrote out these 3 basic questions. So the first one we're going to do is show teams that have over 2 players in the table. Now, we didn't go over this function. It's actually quite helpful, and that is a count. So that'll count how many appearances are in the specific table. So the way that we're going to do this is select, and we're going to have teams, and we're going to do, I should say team, and also count. Put a select star in there, and then from baseball stats. Now, what this is going to show is number of players per team. But before we run that, group by the specific team. And you can see Angels have 2, Dodgers have 2, Padres 3, Phillies 2, Rays 1, and Yankees have 2. So over 2 players, which means that they need to have 3 or above. So group by, and then having, just grab this count, greater than 2. And if we run that, you can see the Padres are the only team in this database that have 3. Up next, show teams that have a sum of 350 hits and are in the NL. So select team sum hits from baseball stats. That's where league equals NL. Group by team. And also I forgot that single one over here. I put a quotes, and then having sum of hits greater than 350. And if we run this, after I name this as total hits, you can see. And if we run this after renaming that total hits, 353 and 470 for the Dodgers and also the Padres. In our last example, so we want to show teams the average home runs in the NL and start with the letter P. So we can grab this over here. We do a select. We grab our team. We grab in our average. Put in here home runs as home runs. Remember, I showed you guys both ways of doing this. From baseball stats, auto populating, then where, and this is where the fun part. So where league is NL, we're gonna do that. We're gonna throw in our and statement. And if you guys remember those wildcards were from earlier, we're gonna say team like, and we're saying start with P. So P like that, and put it over just like that. And one other thing, we need to do our group by. So group by, throw in our team. If we run this over here, Padres and Phillies with 24 and 19 home runs. So one thing I didn't show you guys earlier is case statements. Now the reason is I wanted to show you guys case statements with some complexity in it with aggregate functions. So let's go over a basic case statement first, and then we go into a little bit more complicated one. Now you're going to use case statements quite a lot. In fact, I use them on the daily. So let's start off with our first ever case statement. So formatting wise, let's start this over here. So we start off with case, and then you have when, and this is when something happens. So what I'm going to look at for this case statement is the total home runs over here by player. And I want to have this case statement write out some text based off of how many home runs. So the first one is when home runs is greater than 60. And then we put here then, which is what we want to have happen. So I'm going to say then MVP, which I can't spell, but we have it like this. So anyone that shows over 60 home runs will have MVP populate. And this is going to be a brand new column, and you'll see what happens in a second. So, well, there's a lot of people that don't have over 60 home runs. So we need to have another statement over here. So let's say when home runs is greater than 40, we're going to say then, we're going to say all-star. Isn't bad. let's say over 30, then power hitter. And if a player doesn't hit any of these statements, we need to have an else. So we'll say else average power. Now, at the end of every case statement, make sure you have end, and then you want to name what this column is as type of player. I don't know. And what I also want to do over here is have the specific player so you guys can see how this works. And we'll also put in our home runs. Now we should be good to go. And if we execute this over here, you can see Mike Trout. Well, I made a mistake in here because we have all 60 here and I forgot to change these. So this needs to be 40 and this needs to be 30. And let's rerun this. So let's execute that. And okay, so Mike Trout is a power hitter. That's because we're filtering for above 40. He has only 40. Ohtani, power hitter as well, right? Over 30. Judge, MVP. Stanton, power hitter, over 30. Juan Soto, average power, because average power is anything that is 30 or below. And that is kind of how you build this out as a basic case statement example. But we can start making these a little bit more complicated. So what we can actually do is build out a pretty much a count or a sum based around a statement. And an example I want to show you guys is we're going to sum the amount of players that are in California. So there's going to be 3 teams that are in California. We have the Padres, we have the Dodgers, and we also have the Angels. So how you could do that, have a sum, and we're going to put our case statement here. So case when team equals Padres, then 1, when team equals Angels, then 1, and when team equals Dodgers, then 1, else 0 because you're outside of California in this specific table. We're going to close out, we're going to put end, we're going to close out the sum and total players CA. Now, just to say, there's also a 4th baseball team, the Oakland A's, that are in California, but we don't have that in this table over here. And then we're just going to say from baseball stats. So, and if we run this, so it says we have 7 players in California. Let's go back over here and just do a select star from this table. So I'll just throw that over here. Select star from baseball stats, where team, and I'm going to show you something kind of cool. It's an in statement. So you can actually combine multiple things together. So let's say we're team in Padres, Angels, so Dodgers, and I'll be showing the in statement as well in probably my intermediate course on YouTube. I forgot a comma there. Now let's grab that. We have 7 players that are on the Angels, Padres, and Dodgers. And you can see just by building out the sum with a case statement in it, we also have 7. I will say I see these quite a lot on interview questions, and you do use this a lot at work as well. So something to kind of memorize and familiarize yourself with these. Very, very helpful in the future. New table. So we're going to be using something called Billy Strings Tour. So let's take a look at how this is built out. We have concert number, venue, city, state, capacity, tickets sold, and also songs played. And first thing I'm going to show you guys with this table is rounding, because you see them in so many different questions on LeetCode or other websites like Data Lemur. So what I want to round is tickets sold divided by the capacity. So if we just did that calculation in here, which we can do select tickets sold divided by capacity. And we're also going to throw this venue over here just to show you guys specifically how that works. You can see all of these are going to show as 0, except for KeyBank State Theater, which if we go back to this select star, let me just grab that here. There. That one was sold out. So that one was KeyBank Theater 18 and 18. So that showed as 1, everything else was 0. So we have to round these manually within SQL. Otherwise, you're going to get results like that. And really, zeros and ones, we don't want that data. That's not good data. So what I recommend to do, and this is my own personal method. So if we're going to look at percentage of tickets sold versus the capacity, the first thing I want to do is multiply this by 100. So I go over here and do 100.00 times tickets sold in capacity. Now, if we run this again, you can see that we actually have a lot more results. So 90, we have 91.25, 97.14 goes on forever. And that's already a lot better, right? Better than 0 and 1, but it's not aesthetically pleasing. Realistically, no one is going to want a number like this. So what I recommend is you first cast this as a float. So we'll put cast. And at the very end of this, we're going to say as floats. Close that off. And if we run this now, already looks better because anything that's repeating with these zeros at the very end of 90 is gone. 91.25, 85, and we're almost there. But lastly, we need to round this because I don't want to see a number like this. So let's round it to 2 decimal places. We'll put over here round, and over here 2. And if we run this all over again, you can see how much nicer this looks. And then we're going to name this as sell out percent, like that. And it's built out. So again, how this works specifically, so we're taking tickets sold divided by capacity. We're multiplying that by 100.00. That way it doesn't show it as 0 or 1. We're making this as a float, and then we're rounding that by 2. So kind of just memorize this or write it down somewhere. So up next, I want to teach you guys how to use union statements. And what a union statement allows you to do is kind of combine 2 different queries and output the results into a table. So I think the best is just to kind of show you an example. Let's say I wanted a union Billy Strings tour where he played either in Florida or South Carolina. So like normally, if you're going to do that, we're going to say where state equals Florida or state equals South Carolina. And this is the best way to go about it, to be honest with you. Besides doing where state in and then put both of those. But either way, right, you're going to have these 5 results, and that is how it is built out. But you can actually do a union statement and get the same exact results. So let's say I wanted to select star. This first one over here is where state equals Florida. There's only 2, but we put this down over here. And if I say state is South Carolina, should be 3. And you can see that there's 3 concerts. But if we wanted to combine both of these into one table, instead of these being separated, we're going to put union. So union, just like that. And it's all combined. Now, some caveats on union statements. Again, if you think it's easier that you can put all the filters in a where statement, definitely do that. Where this gets powerful with unions, and also when you're using a union as well, an order by is going to have to be used within a subquery. You're not going to be able to order by here and also here. And you need to make sure that the number of columns are the same from table to table. And you need to make sure that the columns are the same. So you can't have a statement over here select with only 3 columns and another one has 5. You're going to have issues with it. What you can do kind of is like a cheat or like a shortcut on that side of things is you can just declare different columns as null and you're still going to be able to combine them. But really, it's not the best approach on that. But that is how you can use a union It will get a lot better when you start getting into intermediate SQL. But just as a beginner, if you do have this in an interview question, that's probably the best way to know how to use those. So we're now going to take a look at 3 different types of joins. We're going to be looking at full outer joins. We're going to be taking a look at left joins and also inner joins. Now there's another table in this database we're going to take a look at, which is Billy Strings posters. So if we take a look at this one, we have a poster name, we have the concert, we have FOIL number and regular number. Now this specific concert is a foreign key on this table. It links over to this Billy Strings tour where we have a concert num. Now the concert number is the primary key on this specific table. And while I should have probably had these both as concert num, I just want to say, like, when you are working on databases, not everything is going to be properly designed. So sometimes you'll have, for example, user ID, user underscore ID, or sometimes you'll have user ID all together. And you're going to have to learn that database system within your work capacity. Like, okay, that's how you can join different tables by user ID. And you'll learn over time what table has user ID with underscore, which table has user ID all together. And happens quite a lot. So I think this is pretty practical on that side of things. Also to mention, when you start working with multiple tables, you want to have a table alias with it. So for example, if I'm going to use Billy Strings tour, I'm going to probably name this table as BST. And if I wanted to grab a specific column from that, instead of over here, we have the select star, we would do like bst.concert num. And if we do this, right, this all works properly. And I highly recommend that you do this in your own work and also interviews and different things like that, because you can get lost when you do a lot of joins together and also just proper, and it helps a ton with debugging. So I wanted to show you guys that, but I was definitely going to wait until the very end once you kind of got your feet wet a little bit with SQL. So for example, if I had Billy Strings posters, I might just name this as BSP. But let's start going over the different joins. So since we're going to join by these concert numbers, let's show you what a full outer join looks like first. So I'm just going to select star, and what we're going to do is full join, and we're going to grab Billy Strings posters BSP on here. So what I'm going to do is join them, and then what you need to have verbiage wise is on, and this is how we're going to connect the 2 tables. And I've already talked about how concert is going to. So we have bsp.concert, and that has to equal over here bst.concert num. And if we run this, and I'm going to delete that over here, you can see that we have this concert num, venue, city, state. All this is the same for the one table. We have our other table, which is posters. We have all that information here. And we have all of these over here, which are null, and which is good because all of these right here don't exist compared to the posters, and all these don't exist when compared to the concerts. So like there wasn't a poster built out for all of these concerts within the poster table. So that's how the full join works. I'm going to comment this out over here. And next we're going to do a left join. So the left join in this instance is just going to grab everything from the table to the left, which would be your first one on here, which for example, is Billy Strings tour, right? Because Billy Strings posters is joining to it. So if we do a left join, put that back over here, we're only going to get results 1 through 11. We're going to get all those nulls, and then we're going to get 3. All of this down here will not show up. So if we grab that, you can see 1 through 11. Now, if we wanted to do an inner join, that's only going to show the results that are present in both tables. So what's going to happen in that instance is we're going to go down to these specific 2. And there's 2 different ways that you could write out an inner join. So what I recommend is always just type in inner join. It's pretty easy and everyone knows what that is. But a lot of database administrators or data analysts get lazy over time, and you just put join and the same exact results. Now going back into our full outer join, I'm just going to show you guys a few things as well that are kind of helpful. So put this over here and we will grab all this. Let's say I wanted to replace these nulls within the database. How could you do that? Well, there's a function called isNull. So let's say, for example, we're going to do venues. We're just going to grab this specific venues. So we'll put venues over here on this full outer join. And if we run this query over here, you see that there's 3, right? Okay. So let's put isNull, and then we have the venue, which would show. And then let's have something else. So let's say in here, we're going to say concert canceled. Okay. And then you can see now that the nulls have changed to concert canceled, which is kind of cool to see, right? Because you can replace those nulls within your table. But this also goes into your where side of things. So we'll just grab venue over here. And if we run this again, you see that we have these 3 down below. Well, we can also put over here where venue is not null. And this will show us all the venues that are not null. If we execute that, we only have 11 that show now. So with nulls, you add in a lot more functionality as well when you start joining within tables. I want to show you something else that's actually pretty cool, and we're going to do this through a specific inner join. So I'm going to uncomment this last join out over here. Now we've been using the where clause quite a bit. Oh, I should do a select star. I've been using the where clause quite a bit, but the inner join can actually be counted as a where clause. You can add in a lot more filters over here. So let's say I wanted to show where the songs were 24. So I could put in over here, songs played equal 24. And you can see if I do that, only the one shows. If I comment this out, we have both. Again, just like a where clause, I can say where state equals Florida. Both would show on that one. But I could also say, and poster name is beaches. So let's do that. And poster name equals beaches. And only the one shows up on this side of things. So with modern SQL, it's pretty important that you put your additional criterias on your inner join if you have the option to do so. And when you do an interview and you show that you know that, it makes you look even smarter. Well, that is it for our first SQL beginner tutorial. Hope you guys enjoyed it. If you did, make sure to subscribe, as it does help out with YouTube. By the way, I have a full playlist of SQL interview questions. I think you guys should watch these over here and participate as I code these out live. That way you can improve your SQL skills even more.